Hello everyone, and welcome to the Safety Artisan, home of safety engineering training. I'm Simon, and I'm your host as always. But today we're going to be joined by a guest, a human factors specialist, a colleague and a friend of mine called Peter Benda. Now, Peter started as one of us, an ordinary engineer, but unusually perhaps for an engineer, he decided he didn't like engineering without people in it. He liked the social aspects and the human aspects. And so he began to specialize in that area. And today, after 23 years in the business and a first degree and a master's degree in engineering with a human factors speciality, he's going to join us and share his expertise with us. So that's how you got into it then, Peter. So for those of us who aren't really familiar with human factors, how would you describe it to a beginner?
Well, I would say it's the the joint optimization of human machine systems. So it's really focusing on designing systems, perhaps holistically would be a term that could be used, where you're looking at optimizing the human element as well as the machine element. So, and the interaction between the two. So that's really the I think the key to human factors. And of course there are many dimensions, from there. Environmental, organizational, job factors, human and individual characteristics, and all of these influence behavior at work, and health and safety. So another way to think about it is the application of scientific information concerning humans to the design of systems. And systems are for human use, which I think most systems are.
Indeed.
Really,
otherwise, why would humans build them?
That's right.
So,
generally speaking, sure. Yeah.
All right. So, given that this is a thing that people do, then perhaps we're not so good at including the human unless we think about it specifically.
I think that's fairly accurate. I would say that if you look across industries, and industries are perhaps better at integrating human factors considerations or human factors into the design life cycle, that they have had to do so because of the accidents that have occurred in the past. So you could probably say this about safety engineering as well, right?
This is true, yes.
In a sense, you do it because you have to.
Yeah.
Because the implications of not doing it are quite significant. However, I would say the upshot, if you look at some of the evidence, and you see this also across software design and non-safety critical industries or systems, that taking into account human considerations early in the design process typically ends up in better system performance, and you might have more usable systems. For example, Apple would be an example of a company that put a lot of focus into human computer interaction and optimizing the interface between humans and their technologies, and ensuring that you could walk up and use it fairly easily. Now, I guess as time goes on, one can argue how well Apple is doing something like that, but they were certainly very well known for that, taking that approach.
Yeah, and reaped the benefits accordingly and became, I think, they were the world's #1 company for a while, weren't they?
That's right.
So thinking about the why do it? What are the benefits of doing human factors well?
Multiple benefits, I would say. Clearly, safety in safety critical systems, so health and safety, performance, so system performance, efficiency, and so forth, job satisfaction, and that has repercussions, back into the, I guess broadly speaking, into society. If you have meaningful work, that has other repercussions, and that's sort of the angle I originally came into all of this from. But you could be looking at just the safety and efficiency aspects.
Sure. Yeah. But I like you mentioned meaningful work. Is that what attracted you to it?
Absolutely.
Yeah.
Yes.
Yeah.
Yes, I had, like I said, a keen interest in sociology of work,
Mm-hmm.
and looking at work organization, and that's then looking at, for my master's degree, I looked at lean production, which is the Toyota approach to producing vehicles, and looked at multi-skilled teams and multi-skilling and job satisfaction, and then looking at stress indicators and so forth versus mass production systems. So that's really the angle I came into this. If you look at mass production lines where a person is doing the same job over and over, quite repetitive, very narrow, versus the sort of more Japanese style lean production. There were certainly repercussions both socially and individually from a, I guess, psychological health perspective.
Yeah. So you get happy workers and more contented workers,
yeah.
But also, of
better
course,
and better quality. Yeah.
Yeah.
Well.
And again, you mentioned Toyota, another giant company that's presumably grown partly through applying these principles.
They're famous for quality, aren't they? Famous for reliable, high quality cars that go on forever. I mean, that's certainly, when I moved from Canada to Australia, Toyota has a very, very strong history here with, the Land Cruiser and the Hilux and so forth. And
all very well-known brands here, household names, yeah,
known to be bomb-proof and can outlast any other vehicle. And the lean production system certainly has, I would say, quite a bit of responsibility for, the production of these high-quality cars.
Okay, cool.
Yeah.
So we've spoken about, how you got into it, and what is it and why do it. I suppose we've said what is it in very general terms, but I suspect a lot of people listening will want to know, to define what it is, what human factors is, based on doing it, on how you do it. So it's a long time since I did my human factors training, just my one module in my master's. So could you take me through what human factors, involves these days in broad terms?
Sure. I actually have a few slides that might be useful.
Terrific.
I think maybe I should present that. So let me see how well I can share this. Of course, sometimes the problem is I'll make sure that maybe screen 2 is the best way to share it. You see that okay?
Yeah, that's great.
Intro to human factors. So look, Stuart Dickinson, who I work with at Human Risk Solutions, and I have prepared some material for some courses we taught to industry, and I've sort of distilled some of the material, and I'll just flip to some of the key, key slides going through, what is human factors. So let me try and get this working. There we go. I might just flip through quickly. So I guess, as I've mentioned already, broadly speaking, environmental, organizational, and job factors and human individual characteristics which influence behavior at work in a way which can affect health and safety. That's a focus of human factors. or the application of scientific information concerning humans to the design of objects, systems, and environments for human use. So you see a pattern here, fitting work to the worker. The term ergonomics is used interchangeably with human factors. It also depends on the country you learn this in, or that it's applied in.
Yes, in the UK, sorry, I would be used to using the term ergonomics to describe something much narrower than human factors. But in Australia, we seem to use the two terms as though they're the same.
It does vary. You can say physical ergonomics, and I think that would typically represent, when people think of ergonomics, they think of the workstation design, sitting at their desk, heights of tables or desks, and reach, and so on. And particularly given the COVID situation, there's so many people sitting at their desks and probably getting some repetitive strain.
As we are now in our COVID-19 man caves, yes.
That's right. So that's certainly an aspect of human factors work, because that's the looking at the interaction between the human and the sort of desk and workstation system, so to speak, on a very physical, physical level. But of course, you have cognitive ergonomics as well, which looks at perceptual and cognitive aspects of that work. And so human factors, broadly speaking, or ergonomics, again, broadly speaking, would be looking at these sort of multidimensional facets of human interaction with systems. Some other examples might be, an application of knowledge of human capabilities and limitations to design, operation and maintenance of technological systems. And I've got a little distilled or summarized a bit on the right here. Human factors apply scientific knowledge to development and management of the interfaces between humans and rail systems. So this is obviously in the rail context. So, broadly speaking, in terms of technological systems, it covers all of the people issues we need to consider to assure safe and effective systems or organizations. So again, very, very broad. Engineers often don't like these broad topics or broad approaches. I'm an engineer. I learned this through engineering, which is, I think, a bit different than how some people get into human factors.
Yeah, I've met a lot of human factors specialists who come in from a first degree in psychology.
That's right. I'd say that's fairly common, particularly in Australia and the UK.
Yeah.
Although I know you could take it here in Australia in some of the engineering schools, but it's fairly rare. So there's an aviation, human factors, I think, program at Swinburne University. They used to teach it through mechanical engineering there as well.
Okay.
I did a bit of teaching into that, and I'm not across all of the universities in Australia, but there are a few. I think University of the Sunshine Coast has quite a significant group at the moment that's come from, I think, had some connection to Monash before that.
Okay.
Yeah, and really, I sort of, think about when I'm doing this work of what existing evidence do we have or existing knowledge base with respect to the human interactions with the system. So for example, working with a rail transport operator, they will already have, let's say, a history of incidents or a history of issues, and we'd be looking to improve perhaps performance or reduce the risk associated with the use of certain systems. So really focusing on some of the evidence that exists either already in the organization or that's out there in the, in the public domain through, research papers and studies and accident analyses and so forth.
Mm.
I think much like safety, of course, safety engineering, there'd be quite a few similarities in terms of the evidence base.
Indeed, yes.
Or creating that evidence through analysis. So using some analytical techniques, various human factors methods. And that's where human factor sort of comes into its own. It's a suite of methods that are very different from what you would find in other disciplines.
Sure, sure. So can you give us an overview of these methods, Peter?
Sure. There are, I'm trying to think if I have a slide for this. Hopefully I do.
I'm sorry if I've taken you out of sequence.
No, not out of sequence. Let me just sort of flip through, let me take a look at sort of, this is probably a good sort of overview of the span of human factors, and then we can talk about the sorts of methods that are used, for each of these, let's call them dimensions. So we have what's called the long arm of human factors, that there's a large range of activities from the very sort of physical, as we were talking about physical ergonomics, sitting at a desk and so on, manual handling, workplace design, and moving to interface design with respect to human-machine interfaces, HMIs as they're called, or user interfaces. And there are techniques, manual handling techniques, and analysis techniques. You might be using something like a task analysis combined with a NIOSH lifting equation, and so on. Workplace design, you'd be looking at anthropometric data. So you would have a data set that's hopefully representative of the population you're designing for, and you may have quite specific populations. So human factors engineering is fairly extensively used, I would say, in military projects in the military context. And there's
Yes.
a set of standards. The MIL standard 1472G, for example, from the United States, is a great example that gives not only manual handling standards or guidelines, workplace design guidelines in the workplace in the military sense can be a vehicle or or on a ship and so on,
Yeah.
or base and so forth. Interface design, so you'd be looking at, from a methods perspective, you might have usability evaluations, for example. You might do workload studies and so forth, looking at how well the interface supports particular tasks or achieving certain goals.
Mm-hmm.
Human error, there are human error methods that typically leverage off of task models. So you would have a task model and you would look at, for that particular task, what sorts of errors could occur. So there are structured methods for that.
Yes, I remember human task analysis, seeing colleagues use that on a project that I was working on. It seemed quite powerful for capturing these things.
It is, and you have to pragmatically sort of choose the level of analysis, because you could go down to a very granular level of detail, but that may not be useful depending on the sort of system design you're doing, the amount of money you have, and how critical the task is. So you might have a significantly sort of safety critical task, and that might need quite a detailed analysis. So an example there would be, you can look up the accident analysis online. I believe it's the Virgin Galactic test flight. So it was one of these test flights in the US. I have it somewhere in my archive of accident analyses, where the FAA had approved the test flights to go ahead, and there was a task where, I hope I don't get this completely wrong, where the one of the pilots, there are two, pilot and co-pilot in this test airplane, where they had to, in high altitude, sort of near space sort of vehicle is what this was. So moving at quite a high speed, and there was a particular task where they had to do something with, I think they had to slow down, and then you could slow down the airplane, I guess, by reducing the throttle, and then at a certain point, at a certain speed, you could deploy or control the ailerons or some such wing based device. And the task order was very important. And what had happened was pilot or the co-pilot had performed the task slightly out of order. As a matter of doing one thing first before they did another thing, and that led to the plane breaking up. And fortunately, one of the pilots survived. Unfortunately, one of them didn't.
So very severe results of making a relatively small mistake then.
Yeah, and so that's a task order error, which is very easy to do. And if the system had been designed in a way to prevent that sort of the capability to execute that action at that point, that would have been, let's say, a safer design. So at that level, you might be going down to that level of analysis and you would call sort of keystroke level analysis and so on.
Where it's justified. Yes.
Yeah. So task analysis is I think probably one of the most common tools used. You also have workload analyses. So looking at, for example, interface design. I know some of the projects we were working on together, Simon, workload was a consideration.
Yep.
And there are different ways to measure workload. There's a NASA TLX, which is a subjective workload questionnaire, essentially, that's done sort of post-task. But it's been shown to be quite reliable and valid as well. So that instrument is used, and there are a few others that are used. And it depends on the sort of study you're doing, the amount of time you have, and so on.
Yeah.
Let me think. So that's workload analysis, safety culture. I wouldn't say that's my forte. I've done a bit of work on safety culture, but that's more organizational, and the methods there tend to be more around culpability models and implementing those into the organizational culture. So.
Okay, what sort of more governance type issues, that type of thing?
Yes, governance and, oops, sorry, didn't mean to do that. I was just looking at the systems and procedure design. The E is white, so it looks like it's a misspelling there. So it's annoying me. That's okay.
No problem.
Yeah, so there are models I've sort of worked with at organizations such as some rail organizations where they look at, I guess, governance, but also in terms of appropriate interventions. So if there's an incident, what sort of intervention is appropriate? So, if you essentially use sort of a model of culpability and human error, and then overlay that onto or use that as a lens upon which to analyze the incident, and then appropriately either train employees or management and so on, or perhaps it was let's say a form of violation, a willful violation as it may be,
of procedure.
A procedure and so on, versus a human error that was encouraged by the systems design. So you shouldn't be punishing, let's say, a train driver for a SPAD if the SPAD.
Sorry, that's a signal passed at danger, isn't it?
That's right. Signal passed at danger. So it's certainly possible that the way the signaling is set up leads to let's say a higher chance of human error. You might have multiple signals at a location, and it's confusing to figure out which one to attend to, and you may misread,
Mm.
and then you end up spadding, and so on. So there are, for example, clusters of spads that will be analyzed, and then appropriate analysis will be done. And you wouldn't want to be punishing drivers, if it's seen to be a systems design issue.
Yes. Yes, I saw a vivid illustration of that on the news, I think last night. There was a news article where there was an air crash that tragically killed 3 people a few months ago here in South Australia, and the newsies reported it as saying it was human error. But when they actually got into reporting what had happened, it was pointed out that the pilot being tested was doing, it was a twin-engined aeroplane, and they were doing an engine failure after takeoff drill. And the accident report said that the procedure that they were using allowed them to do that engine failure drill at too low an altitude. So if the pilot failed to take the correct action very quickly, and bearing in mind this is a pilot being tested because they undergoing training, there was no time to recover, so therefore the aircraft crashed. So I thought, well, it says a little bit unfair just to say it's human error when they were doing something that was intrinsically inappropriate for a person of that skill level.
That's an excellent example, and you hear this in the news a lot: human error, and human error. The cause of this, I think, with the Boeing, the recent Boeing problems, with the flight control system. I think for the new 737s, and of course there will be reports. Some of the interim reports already talk about some of the human factors issues inherent in that, and I would encourage people to look up the publicly available documentation on that, be it through some of the.
This is the Boeing 737 MAX accidents in Indonesia and Ethiopia, I think.
That's correct. Yes, absolutely. And pilot error was there. It was used as the general explanation, but under further analysis, you start looking at, well, that error, so to speak, error, has perhaps other causes, which are systems design causes. Perhaps, right? So these things are being investigated, but have been written about, I think, quite extensively.
Yes.
And you can look at, of course, any number of airplane accidents and so on. There's a famous Air France one flying from Brazil to Paris, from what I recall. So it might have been Rio de Janeiro to Paris, where the pitot.
Pitot probes got iced up. Yes.
Probes. They iced up, and it was dark, and so the pilots didn't have any ability to gauge by looking outside. I believe it was dark. It might have been a storm. There was some difficulty in gauging what was going on outside of the airplane, and there were getting misreads. So stall alarms going off and so on. I believe, or perhaps there was no. There were some misreads on the airspeed coming from the sensors, essentially.
Yes.
And then the pilots acted, according to that information, but that information was, incorrect. So you could say there's probably a cascade of issues that occurred there, and there's a fairly good analysis one can look up that looks at, the design. I believe it was an Airbus.
Yes,
I think the design of the Airbus. So, we had one pilot providing an input in one direction, entering the control yoke, and the other pilot in the other direction.
Yes.
So there are a number of things that broke down, and typically you'll see this in accidents, is that you'll have a cascade as they're trying to troubleshoot and can't figure out what's going on. they'll start applying, various approaches to try and remedy the situation, and people begin to panic and so on. And you have training techniques like crew resource management, which certainly has a strong human factors, let's say, element, or comes out of the human factors world, which looks at how to have teams in cockpits and in other situations working effectively in emergency situations. And that's sort of after analyzing, of course, failures. So
yes, and I think CRM, crew resource management, has been adopted not just in the airline industry, but in many other places as well, hasn't it?
Yeah.
I think
operating theaters, for example, there's quite a bit of work in the 90s that started with, I think it was David Gaba, who I think was at Stanford. This is all from memory. And that then, look at operating theaters, and in fact, Monash Medical Center in Clayton had a simulation center for operating theaters where they were applying these techniques to, training operating theater personnel, so surgeons, anesthetists and nurses and so forth.
Yeah.
So.
Okay. Well, thanks, Peter. I think I'm sorry. I think I hijacked your presentation, but maybe
it's not really a presentation anyway. It was, I think, more sort of a bit of guidance there. We were talking about methods, weren't we?
Yes.
And it's, I guess, easy to go then from methods to talking about accidents. Because then we talk about the application of some of these methods, or if these methods are applied to prevent accidents from occurring. So
cool. Well, thanks very much, Peter. I think maybe I'll the next time we have a chat, I'll let you talk through your slides, and we'll have a more in-depth look across the whole breadth of human factors. So
probably a good little intro at the moment. Anyway, perhaps I might pull up one slide on human factors integration before we end.
Of course.
If I sort of go back a few slides here. And so what is human factors integration? I was thinking about this quite a bit recently because I'm working on some complex projects that are, very, well, not only complex, but quite large engineering projects with lots of people, lots of different groups involved, different contracts, and so forth. And, the integration issues that occur, they're not only human factors integration issues, they're, larger scale integration, I think, issues, engineering integration issues, generally speaking. And this is something I think that projects often struggle with. And I was, really thinking about, the human factors angle and human factors integration. So that's about ensuring that all of the HF issues, so HF being human factors, in a project are considered and controlled throughout the project.
Yeah.
Deliver the desired sort of performance and safety improvements. So, three functions of human factors integration: confirm the intended system performance objectives and criteria, guide and manage the human factors aspects in design cycles so that negative aspects don't arise, prevent the system reaching its optimum performance level, and identify and evaluate any additional human factor safety aspect not already found in the safety case. And you'll find, I'd say, particularly in these complex projects, that the interfaces between you might have quite a large project and have sub-projects working on particular components. Let's say one is working on more of a civil sort of structural elements and maybe space provisioning and so on, versus another one is working more on control systems. And the integration between those becomes quite difficult because you don't really have that human factors integration function working to integrate those two large components. Typically, it's within those focused, let's say, project groupings. That's the way to call them. Does that make sense?
Yeah, absolutely.
So
yes.
I think that's one of the big challenges I'm seeing at the moment, is where you have a certain amount of course, time and money and a resource, and this would be, I think, common for other engineering disciplines. And the integration work often falls by the wayside, I think. So, and that's where I think a number of the ongoing human factors issues are going to be cropping up on some of these large scale projects for the next, 10 to 20 years. So both operationally and perhaps safety as well. So of course we want to avoid. So
yes, I mean, what you're describing sounds very familiar to me as a safety engineer, and I suspect to a lot of engineers of all disciplines who work on large projects. They're going to recognise that as a familiar problem.
Sure, you can think about if you've got the civil and sort of space provisioning sort of aspect of a project, and another group is doing what goes into, let's say, a room, into a control room or into a maintenance room, and so on. It may be that things are constrained in such a way that the design of the racks in the room has to be done in a way that makes the work more difficult for maintainers, and it's hard to optimize these things because these are complex. They're complex projects and complex considerations, and a lot of people are involved in them. I guess the nature of engineering work is typically to break things down into little elements, optimize those elements, and bring them all together.
Yes,
and
yes.
Human factors tends to, you can do that in human factors as well, but I would argue that certainly what attracted me to it is that you tend to have to take a more holistic approach to sort of human sort of behavior and performance in a system.
Absolutely.
Which is hard. So
yes, but rewarding. And on
yes.
that note, thanks very much, Peter. That's been terrific, very helpful, and I look forward to our next chat. Okay.
For sure. Me too. Okay. Thanks.
Cheers. Well, that was our first chat with Peter on the Safety Artisan, and I'm looking forward to many more. So it just remains for me to say thanks very much for watching and supporting the work of what we're doing and what we're trying to achieve. And I look forward to seeing you all next time. Okay, goodbye.